we're going to talk about vector fields. One of the examples of vector fields are actually weather map. You also have magnetic fields. Magnetic fields are also examples of vector field that we're going to discuss in our class. Very good. So let us start by basic definition. Suppose D is a set in the plane. Let D be a subset of the plane. A vector field on the plane is actually a function. We're going to use bolded letter F to represent vector functions. So what does this function do? It assigns to each point like X and Y. In the region D, a two-dimensional vector, that we're going to represent that by F of X and Y. So we have a function. What does this function do? You have some input values. Input values are ordered pairs, X, comma, Y. So you have a starting point, which is located at X and Y. And then you have some outputs, which are in vector form, F of X and Y. And this is your function F. It takes some starting points. So you have some points, you plug them into the function, and the output values are vectors. Very good. Let's take a look at one example. The example says, a vector field on R2 is defined by so you are just working with some vectors in the plane. That's why we use R2 is defined by F of X and Y, which is equal to negative Y in the direction of X-axis. So that's why we use I plus X times J in the direction of Y-axis. We want to describe this vector field. Let us describe this vector field. Here we have two options. Option one is actually using paper and pencil and a table, plug in some points and see what are some vectors. Option two is using technology. So first of all, let's work with option one, use paper and pencil. What do I mean by that? It means that, hey, you have some points like X and Y, and then you have a vector like F of X and Y. Okay, if I plug in 1 and 0 into this function, I have negative Y. I'll write down the whole thing here to avoid any confusion. Negative Y I plus X J. So my Y is equal to 0. I get 0 I plus 1 J. Or in vector form, we have 0 and 1. Let's plug in another value, like -1 and 0. If I have -1 and 0, -1 is for my x and 0 is for my y. So it becomes 0i minus 1j, or 0 and -1. Let's plug in another value, another point, like 1 and, for example, 1 and 1. You can use that, or you can plug in, for example, 0 and 1. Why not? If you have time, you can plug in as many ordered pairs and then find the vectors associated to those x and y's and then graph them. So my x is 0, my y is 1. So here it becomes -1i plus 0j, or -1 and 0. You can plug in, for example, 0 and -1. 0 is your x, -1 is your y. So this guy becomes negative times negative, which is positive, 1i plus 0j, or 1 and 0. Again, if you have time, continue this process. So how do I visualize this guy? I have x-axis. I also have y-axis. At 1 and 0, this is the point, 1 and 0. I have vector 0 and 1. I'm going to use a different color. 0 and 1. The length of this vector is just 1. This is vector 0 and 1. At -1 and 0, this is point, -1 and 0. The vector that you have is 0 and -1. Very good. So what do we have here? 0 and -1. This is my vector. Next point, at point 0 and 1, I have a different vector. 0 and 1, my vector is -1 and 0. Just in the same direction here. -1 and 0. And finally, at the point 0 and -1, which is this point here, I have vector 1 and 0. Use a different color for you. Here we go. So again, if you have time, you can continue adding more vectors to this vector field and analyze the behavior of this vector function. Option 2 is using technology, much more faster and much more accurate. But for the exam, you need to know how to graph these without using technology. So in a bit, we're going to see how we can graph these types of functions and see the behavior using online websites. So here you have a 2D vector field. Your I component is equal to -y, and your x and your y component is just x. So let us just graph this guy. This is the behavior of your vector field. You can change the scale. Hope it applies here. If not, that's fine. So this is the behavior of vector field that we actually graphed only 4 vectors. You have 4 vectors here. You can actually see the behavior of the vector field by adding more vectors to it.